So, hello and welcome to the second grade section of our starter kit in adding Houdini to your Arsenal 2.0. This second section of our starter kit is always centered around one project that we're going to create, and it's this flower tube project that you also saw in the teaser. Now, in this week we're going to build the first part of a flower tube, and we're also going to look at groups. Then, as always, we're going to take a break for 1 week, and then the week after we're going to publish the videos on airtrips and airtrip classes, as well as the second part of a flower tube. And then again, 1 week break, and in the week after we're going to take a look at all the different ways that you might want to render this project that we're creating here. Hopping over to Houdini, a flower tube at the end of this section today won't end up looking like this, like in the teaser. It will end up looking like this. So this is our first part. This is the main setup, and in the second part we will take a look at all the different ways we can add variation to a setup to make things look more interesting. But for now we keep things simple like this, and we add a simple simulation to it like this. Now, talking about the simulation about all of this, there's a couple of things we can take into consideration here. I built a quick demo file for this. You don't have to worry about all those nodes in here. It's more about the core ideas. So for now, you don't have to rebuild any of this. So how could we simulate a simple flower tube like this in our setup? Well, there can be two ways. So the first way is we could start out first of all with a line, and then we could actually build the whole geometry of a flower tube. And then, since this geometry looks sort of like a cloth, we could wire this into a vellum cloth constraint node, and then run this through a vellum solver. And I added a little tube as a collision object in here. And if I play and take a look at the animation, this looks very squishy and accurate. This is what we want. But there's also a different way we could do this, and this one looks something like this. We start out again with a line, but instead of building our actual geometry, we turn this line into a vellum hair object. And a vellum hair object has some thickness to it, roughly the same thickness as a flower tube. And we can run this through a simulation, and this looks something like this. And what we can do then is just build our actual geometry after our animation. So like this, and if we play this, we can see that our result looks very similar to our first result. And in fact, we can also compare both of them. And the result, while a bit different, is pretty similar. The difference between those two approaches, this one and this one, is in here, right before our vellum nodes, we are feeding in a total of 130 points. And in here, before our vellum nodes, we're feeding in just 10 points. So we should expect that this simulation right here runs around 10 times faster than this simulation right here. And if we want to add hundreds or even thousands of those tubes to a simulation, I think this is a better approach because it will be much faster. So this is the approach that we're going to take for this video or this setup. And of course, as always, it's a good idea to make some small tests beforehand before I jump into a big project, because you may find those easy and very fast setups like this. But now let's actually jump into an empty scene. And again, as always, I removed my parameters window up here. You can take a look at our first squishy vellum setup if you want to see how I did this. And I want to start building my setup. First of all, we again need an empty geo container. So let's search for geo. Let's drop down the geometry node and jump inside. And I want to start out by building the base tube where all my flowers will sit on. The base tube will be a roughly circular shape, and I want to draw this using a curve node. So let's search for curve. We got a bunch of options right here, and in this case I want to use the curve node with the Bezier preset. So this will be this one right here. Let's drop this down. I need to bring up my parameters panel by hitting P. And I want to draw my curve in the viewport, and for this I want to jump into the top viewport, so right here. And what I want to draw in here is a sort of oval shape. So let's jump into our handles tool. On top of here we should see a menu that's sort of similar than what you might be used to from Illustrator. We can make sure that we're in the Bezier mode and that we're using the pen tool. And now we can start drawing a curve. And I want to start out sort of here, drag my handle out from here, and go to here, drag my handles out to, let's say, here, go to here, drag my handles out, again roughly in the same shape as up here. I can make my way around the circle and then again in the end up where I started, which leaves me with this closed shape right here. Now to make this a bit more interesting, I can jump into the perspective viewport. I can jump into the edit handle right here, and I can start tweaking the handles of my curve, and maybe I want to angle those two handles right here at the narrow side of my curve, and then also tweak the handles on the broad side of my curve to get a shape that sort of looks like the infinity symbol if I look at it from the side, something like this. Now at the moment this of course looks like a plane but not like a tube, so to make it a tube I need to sweep it. So let's drop down a sweep node where I'll curve in. Again the sweep node is complaining, and it's complaining because it's expecting a second input, but in this case I don't want to use the second input, I just want to use a round tube. Let's maybe increase the divisions of this a tiny bit. In the end I chose a value of 18, but our curve sort of looks a bit weird. We get these long, stretched and bent faces. Well, right now this is a Bezier curve, and if you take a look at the point display on this curve by hitting this button right here, we can see that we have points for just the midpoint and the handles on each part of a curve. And what this is not is a polyline, and Houdini likes working with polylines in most cases, so we have to turn it into a polyline. The quick way to do this for a curve is to use a node that's called resample. So I can search for resample and wire this below my curve. And if I set my display flag at this node and take a look at my points, now I got evenly spaced points on my curve all the way around. And this is in the end what I want for my sweep node, because now I get an output that I expect. I get loads of very tiny faces on my curve. I want to tweak the length of my resample node to make these faces roughly square, and in this case I want to change the length, the segment length of my resample, so how long each of these lines are. I want to set this to a value of 0.03, like this, and now also my sweep node looks a lot better. Now with this sweep node done, we can take a look at the volume simulation that we want to drive on top of this node. And for this, first of all, I want to place a lot of lines randomly on this curve. What I want to use for this in the end is, well, first of all, a line node. And I want to make the length of my line node a lot shorter. Let's say maybe a value of 0.2. And to put it onto my curve, I want to use a copy to points node. The copy to points node is pretty much the Houdini way of using, for example, a cloner inside Cinema 4D. We have one input for the object that we want to copy or that we want to clone, and then another input for the geometry we want to clone too. And if we take a look at the result, we now have hairs on a curve. Right now they look a bit weird. This is first of all because they're not standing directly on the surface, they're sort of angled. And this is because on a line node we want to set the direction not to the y-axis but to the z-axis. So let's here on the direction add a 0 on the y position and a 1 on the z position, like this. And now this looks a lot better, but still our curves are very evenly spaced, and this is because right now, all our points on our torus object right here are arranged in this grid spacing, which is of course not very random. So what we want to use instead is a new node that is called scatter. And what scatter does is scatter places points at random positions on our object and then also relaxes those points a bit so that they all have somewhat the same distance to one another. And I can set a total count. In this case I want to leave this at 1000, and then also some relax iterations that make our spacing either more random if this value is low or more even if this value is high. And I want to also leave this at 10. Let's wire this into our copy to points. This looks better, but it's still a bit weird. Why is it weird? Well, all our lines are pointing into the same direction, and there's a fix for this, which looks right now very weird, but this is something that we want to take a deeper look at in the second part of the setup. The fix right now is to simply drop down a normal node under our sweep node. Now we got our hairs on our base surface. Before we want to go into the simulation, we also want an object to collide with all our hairs. So I want to have a torus that travels down this curve, down this path that we defined. So for this, we first of all do need a torus. So let's create one. We have a torus in our scene, and I want to change the minor radius of a surface to a value of 0.05 to make it a lot thinner. And I also want to change the uniform scale to a value of 0.5 to make it a bit smaller. Now to make it travel down the curve, I could of course use keyframe animations, but this would be a bit tedious. So what I want to use instead is I want to use my path that I defined here, and I want to use a path deform node to move my torus along this path. So let's drop down a path deform. Our torus goes into the first input, and then our sample node goes into the second input. And now I have this slider right here, in this curve view slider, where I can move my torus along this path. This is of course the wrong orientation, so let's change the orientation of our torus. And again, I want to have my torus oriented along the z-axis, like this. And if I maybe ghost my sweep node like this, and have my display flag on my path deform and play with the curve view position, I can make my torus travel along my path. And again, I want to have this animated, and again, I want to animate this using an expression. And in this case, I want to use not $f, but $t. $t is the current time in seconds on my timeline, which in most cases is a bit more handy than $f, because if I later want to change the frame rate of my animation down here, my animation does not change. So in this case, let's write $t, and I also multiplied this by a value of 0.1. Let's take a look at the result. Let's hit play on our timeline, and we can see the torus is traveling down our curve. And as we can see, we have a timeline of 240 frames, which is exactly 10 seconds. So in this case, our torus makes one perfect round around the path that we defined. And we can also change even the length of the path, and our torus will still make a perfect looping animation around the path. Now our scene is currently getting a bit cluttered, so let's make this a bit more orderly, a bit more easy to read. And I want to make this easier to read by using, first of all, again, network boxes like up here, and then also null nodes. Null nodes do exactly nothing to our geometry, but they're a great visual marker for larger setups. So let's drop down our first null node, wire this below our resample node, and then also replace all the connections with our null. And we can call this null right here the base curve, like this. And we have our torus and our path deform, and we can drop down another null for those, and this will be our collider. Then we have our base mesh, our base ring. This is our sweep node, so let's add a null in here, call this base ring. And then finally we have our lines on our ring, and this will be our flower base. So let's drop down another null like this. And what we can do also is for each section make our nodes a bit more neat, and then encase each section also in a network box. And this might look a bit excessive what we're doing right here, because we have very few nodes in each network box, but as our network will get larger in the future videos, those boxes also will get a lot larger, and in the end we'll have a setup that's much more readable if we organize it something like this. Now we have all our base elements. Let's focus on the simulation. For this again, I want to use a vellum hair node. Let's drop down a vellum configure hair. Let's wire this in. And on my hair, I want to set the right thickness to match the flower objects that I want to build on those lines in the end. So for this, first of all, on my vellum hair node, I want to visualize the thickness. This puts a tiny ball on each point on my curve, and I can see I forgot something very important. Right here on my line node, I can set the number of points in my line, and right now this is just 2 points, so 1 at each end, and this is of course a bit too few points for our simulation, so let's set the number of points to 10. And now again, let's take a look at the thickness visualization. Right now all those hairs are very, very thin, but I can slowly increase this maybe to a value of 2 to make this look a bit more interesting. Now let's wire this into our vellum solver, wire all the inputs up like this. And for now, let's simply hit play and see what happens. And as we can see, all our hairs are falling down and then spreading out. This is of course not what we want. We want our hairs to stay in place. So inside most of these vellum constraints nodes, we have a way to do this. We have here a point group, which is called pin points. And in this point group, we can select points that we want to pin in animation that would stay in place. So we can, for example, select this endpoint right here and this endpoint right here, and then maybe also this endpoint right here. And let's hit enter and then sim again. And all those hairs where we defined those points are now staying in place and not falling down. But of course we have a problem, because in the end we have 1,000 of these hairs, and right now we're selecting each one manually, which of course would be crazy to do for each one of those thousands of hairs. So how can we solve this? We can solve this using a feature of Houdini that we haven't talked about before. That is a very important feature of Houdini. And in fact, in the next video of the series, we're going to talk about this feature in detail. Right now, we're just going to use it for a very simple case in here. And that feature is that we can not only define groups manually in this field, we can define groups using other nodes as well. So for now, let's delete everything that is in this field right here. And we can drop down a new node, a node that we haven't used before, that is called group. So what we can do inside a group node right here is we can, for example, wire this up in front of a vellum hair node. And in this group node, we can define a group that we can later use down here in this group field on a vellum hair node. So how can you do this? Let's start on top of this node. First of all, a very important thing for each group is each group should have a name. In this case, we're going to call our group pins. And this could be any name. This is just a very descriptive name for our setup. Then we need to select what type of geometry we want to group. Right now this is set to primitives, which in this case is each hair curve. But of course, down here in our vellum hair node, we selected points. So our group here should also be points. And then again, we have a group field. And in this group field, we could again manually jump in and select endpoints. So let's maybe select both of these and hit enter. And now both of these points are in this group field right here. And then down here at our vellum hair, we can jump down to our pinpoints and use this little drop down menu right here. And in here we can select the pins group. Now it's important at this point that you have your display flag down at your vellum hair node set, because if you don't set this, this node might not be cooked yet, so you may not have access to this pins group. So just make sure that the blue display flag is set when you select your group right here. But now, if we have our group selected and we play our simulation again, those 2 points that we selected are staying in place. But of course, this hasn't solved our problem yet. In here, we would still need to select each one of those thousands of points, which is not what we want. But we can make use of the fact that this is happening in a different node than this node right here. And we can move this node to other places upstream in our node editor. So what if we, for example, shake our group node right here free and we move a group node up to a single line up here. And on a single line, we are again going to select some points. Let's delete all the entries in here and again use our selection arrow. And I want to select the point that's right here on the 0, 0 point, because this is the root or the bottom of a hair. So let's select this point. Let's hit enter. Now this point is grouped. Let's see what happens if we play our simulation at the end. And as you can see now, all our hairs are pinned. So what happened here is right here we set the pin point for a single line, and this group travel down the entire geometry stream down to a vellum hair node where we can use it. And since we have a copy to points node in here, this group is now on every copy of a line that we're creating here. So every line has its root point in this pins group. Now this concept that one node up here isn't really changing the geometry that we're feeding through it, but it's just adding data to the geometry, and then we can use this data later downstream, is a concept that's very, very, very important in Houdini. And we will take a much more detailed look at this concept in the next videos after this one. For now, let's keep going. I want to add a bunch of collision objects to my simulation. And those collision objects will be, for example, my base ring and also my collider object. So what I can do for those is simply drop down a merge node, go from this node into a merge, and from this node into a merge, and from this merge node into the collision input of my vellum hair. And if I now play my animation again, now our torus is colliding with all those hairs and adding a bit of animation to them. What I can see happening if I take a look at one single hair is something that looks a bit odd. We have our standard hair curve right here, and then we have this jump, and then we're back at a normal hair curve. And this is simply because Our collider here, our base collider, is a bit too big, and this pushes some of the hair points up to one side, which leads to all those kinks on those hair curves. There's a simple way I can fix this. I can make the base ring as the collision object a bit smaller, and I can make this smaller using a node that's called peak. What a peak node does is it just moves the surface of an object alongside its normal vectors, so essentially enlarging or shrinking an object. Let's jump back to frame 1. Let's wire this peak node into our base ring that goes down into a merge, and then simply make the distance a bit smaller, maybe a value of 0.02. Let's test this. And now all these kinks are gone. I also want to tweak my volume solver a bit. I want to jump into the forces tab and first of all turn down the gravity to make this look a bit like we're underwater, for example. And if I play this again, yeah, now this animation looks a bit more interesting, I think. That's all I want to tweak in the setup for now. The last thing that I want to do is I want to actually turn all my lines here into those flowers. And for this, again, I want to use a sweep node. Let's wire this in. Again, the sweep node is going to complain because it wants a second input. And in this case, I do actually want a second input as well. I want to use a spiral for this. Let's drop down a spiral node. Let's wire this in our sweep node. Right now, this looks very, very strange. So let's fix all the right parameters on here. On my spiral, I want to decrease the turns to a value of 1.5. And I want to set the divisions per turn down a whole lot to make our geometry a lot easier to process. I want to turn those down to 8. Let's take a look at this. Again, this still looks a bit wrong. What's wrong is, again, the orientation of our spiral is in the right direction and we want the Z direction. So for this, let's drop down a transform node and rotate our spiral on the x-axis a value of 90 degrees, like this. Let's take a look at the sweep node now. Now this is oriented the right way, but we're looking at the inside or the backside of each face. So to fix this, I want to use just a value of minus 90 degrees, like this. Also, I want to make my curve a bit bigger or a bit wider. So let's turn up the uniform scale, maybe to a value like this. So all the tubes are almost touching, maybe a value of 3.5. And then to make this more interesting, I want to go into my sweep node and I want to apply a scale along my curve. So let's add a check mark right here. And this gives us access to this ramp. And I can make this ramp a bit larger by hitting this button right here. And I can simply click and drag into my ramp to add new control points. And I maybe want a shape that sort of curves up like this. Maybe this is a bit drastic. Let's make it a bit thicker. Maybe something like this. And also I can select all my points on this ramp by first selecting this point at the left and then shift selecting this point here at the right. And then I can set all of those points, for example, to B-spline to make the transition a whole lot more smooth. And then finally, I also want to apply a twist to my entire geometry, and I can apply this twist by simply setting the full twist on my geometry to a value of -1, for example. And this in the end leaves me with this flower geometry right here. And I think I like a full twist of 1 better instead of -1. Yeah, I think this looks a bit better. So let's take a look at this. And this is sort of working, but the tops of all my curves are a bit jittery. And I can simply fix this by scrolling up here and unchecking this stretch our turns parameter right here. So if I play again now this is all nice and smooth. Now the final thing that I want to fix in here is maybe the normals of this curves, because I maybe have some sharp angles in here. And for this again, I'm going to use a normal node and set the cusp angle to 180 degrees, like this. Now we're pretty much done for this video. We're again going to drop down a null. This will be our flower mesh. And then we're going to take all of this, maybe make this first of all a bit more neat, like this. And then again encase all of it in a nice network box. And then finally, to get a preview, we can drop down a merge node and in here wire in our collider, our base ring and our flower mesh. And we can take a look at our end result and play our animation and see what we get. And I think we have a pretty good start for our flower tube setup right here. So this is it for this video. What we're going to do in the next video is we're going to take a lot deeper look at this group mechanic that we took a look at in this episode right here. But until next time, it's cheers and goodbye.